Hello, I am at my service project today, so I'm just gonna give you guys a super quick video of today's lesson, and then I will also upload a PDF of the notes, so you can just copy those notes and hopefully it will make sense. And then tomorrow when I am back, we will go over it and you can ask any questions that you have. So we're doing chapter 5, lesson 2 today, polynomials, linear, factors, and zeros. So we've kind of done these concepts before, which is why I feel like I can go through it kind of quick. So if we start down here with our examples, we're gonna write the polynomials in factored form. So remember, when we're factoring, the first thing we do is take out our greatest common factor. So whatever all of the terms have in common. So on this first one, they all have an x. So if I take out an x, I'm left with x squared plus 8 plus 15. And then I can factor it with factors of 15 that add to 8. So that would be 5 and 3, because 5 times 3 is 15, 5 plus 3 is 8. So I keep this x, and then I have x plus 3, x plus 5. And that is all I can do. So that is my polynomial in factored form. On the next one, it's x to the third minus 81x. So my greatest common factor, they both have an x. So the first thing I do is factor out an x, and then I'm left with x squared minus 81. You might notice x squared minus 81 is a difference of squares. So x squared and 81 are both perfect squares. The square root of x squared is x. The square root of 81 is 9. So I'm going to keep my x out front, and then I'll have x plus 9 and x minus 9. And that is my full factored form of that polynomial. So on this next one, my greatest common factor, once again, is x. They all have an x. So I will take out an x, and then I'm left with 2x squared minus x minus 10. So then, since I have a coefficient out front that is not 1, I have a 2 out front, I'm going to have to use my airplane box method. So 2 times 10 times negative 10 is negative 20. So factors of negative 20 that add to negative 1. And that's when we can draw our box, if this is the method you like to use. So you put your 2x squared, your negative 10, and then your factors of negative 20 that add to negative 1 would be negative 5x plus 4x. So negative 5x and 4x. And then I go through my box and I find my greatest common factors in each row and column. So with 2x squared and 5x, it's x. With 4x minus 10, it's 2. 2x squared and 4x, my greatest common factor is 2x. Negative 5x and negative 10, it's negative 5. So this one would be a plus. So I keep this x from the very beginning out front. So then it's x times x plus 2 times 2x minus 5. And that's it. On my next one, the greatest common factor is x, once again. So I factor out an x, and then I'm left with x to the third plus 64. And then I have to figure out how I can factor x to the third plus 64. So that is when they're both cubes, they're both perfect cubes. If you remember this, it's been a minute since we factored the perfect cube thing. So x to the third power, the cubed root of that is x. And then a number that you can multiply by itself 3 times and get 64 is 4, because 4 times 4 is 16, and 16 times 4 is 64. So we're going to keep this x out front. And then remember, the cubed root of x cubed is x. Cubed root of 64 is 4. And then this is when you do the same opposite plus for the signs. So since this is a plus sign, the same sign is a plus. And then for this part, you do the first number, like the x squared. So it's going to be x squared. And then you multiply them together, so that would be 4x. And then you do the last number squared. So it would be 16, because 4 squared is 16. So we did the same sign for the first one, and then we do the opposite sign, which is minus, and then plus. So for my final answer, I have x times x plus 4 times x squared minus 4x plus 16. That cannot be factored any further, so then I just leave it at that. That is my furthest factored problem. Okay, for the next one, we're just finding the zeros of each function and then stating the multiplicity of this, multiplicity? I can't say that word very well, of the zeros, and then determine the degree and behavior of each function. So if we are finding the zeros, all we have to do is set each thing equal to 0. So x plus 9 equals 0. Well, if x plus 9 equals 0 and I'm solving that, then x would be negative 9. If x minus 3 equals 0 and I solve that, x would be 3. If x plus 2 equals 0 and I solve that, x would be negative 2. And then this one, the degree, right? I was supposed to determine the degree? Yeah. The degree of this would be 3, because if I multiply this out, I have 3 x's, and so the greatest degree I would have would be x to the 3rd power, because once you multiply x times x times x, you get x cubed. So the degree would be 3, which means it's cubic. For 6, I would just set each thing equal to 0, so I would have an x equals 0, and then x minus 5 equals 0, which would mean that x is 5. If I solved x minus 5 equals 0, I would get x is 5. And then this is x minus 5 is squared, and then times x. So I would end up once again with 3 x's. So the degree is 3 again, and it's cubic. For 7, this x is cubed, and then we have 2 more x's. So this one's cubed, 4, 5. So there's 5. So it would be x to the 5th power. So it would be quintic. I'm going to spell it wrong if I don't check. Quintic. Quintic. So it's to the 5th power. And then I'm just going to set each thing equal to 0 and solve it. So 2x equal to 0. Well, then x would just be 0. If x plus 3 is 0, x would be negative 3. If x minus 1 equals 0, x would be 1. On number 8, we're going to, first we have to factor it. It's not factored yet, like these ones were. So first I take out my greatest common factor. That's always how I start factoring. So I would take out a 2, because that is what they all have in common. So I would do 2 times x squared minus 8x plus 16. Then I need factors of 16 to add to negative 8. Well, negative 4 times negative 4 is 16, and it adds negative 4 plus negative 4 is negative 8. So I keep my 2 out front still, and then I would have x minus 4 times x minus 4. And I know that my degree, I guess I should have said that, I don't know, is quadratic because it's squared. So if it's squared, it's a quadratic. The highest degree is 2. I can't write anymore. There we go. Quadratic. Highest degree is squared. And then 2 equals 0 isn't actually a solution, so I can kind of just ignore that. And then the x minus 4, if I solve that, I would get x equals 4. X minus 4 equals 0, solving that for x, we get x is 4. All right, this one's already factored for me, so I just need to set each of these equal to 0. And there's 2 x's. If those were multiplied together, I would end up with x squared, so it is another quadratic. And then x minus 5 equals 0, x would be 5. 2x plus 1 equals 0, you would subtract the 1 over, so you'd have 2x equals negative 1, and then divide by 2, so x would be negative half. Okay, these ones are kind of fun, in my opinion. We're going to write a polynomial function in standard form with the given zeros. So, if x could be 2, negative 2, or 4, we're basically working backwards to the problems above. So that means that my function, f of x, had an x minus 2 in order for 2 to be a solution, an x plus 2 in order for that to be a solution, and an x minus 4 in order for that to be a solution. Notice it's the opposite sign because when I solve each of these, when they're set equal to 0, I should get this. So it's the opposite signs, x minus 2, x plus 2, and x minus 4. And then if I want to write this as a function in standard form, I'm just going to have to multiply these out and then put them in order of decreasing degrees or decreasing exponent powers. So x minus 2 times x plus 2, we would FOIL this. So first, x times x is x squared. Outside, 2 times x is 2x. Negative 2 times x is minus 2x. 2 times 2 is minus 4. And then I would have to take that times x minus 4. First I can, this has a 2x minus 2x, so that just goes bye-bye. So I have x squared minus 4 times x minus 4. So I'm just going to FOIL it one more time. So my front number, x squared times x is x to the third. X squared times negative 4 is minus 4x squared. Negative 4 times x is minus 4x. Negative 4 times negative 4 is 16, so plus 16. So my final answer is that the function, so f of x equals x to the third power minus 4x squared minus 4x plus 16. 2 more. We got this. Okay, so if an answer is negative 3, that means that it was x plus 3. If an answer is 0, then there's just a plain x. Yeah. And then if an answer is 5, then it would be x minus 5. Okay. So then we're just going to multiply these out. So I would FOIL first and then distribute that x through. So x, first numbers, x times x is x squared. Outside would be negative 5x, 3 times x is 3x, 3 times negative 5 is negative 15. And then we still have that x out front. We can combine our like terms, so negative 5x plus 3x is negative 2x. So then I have x times x squared minus 2x minus 15. I distribute the x, so I have x to the third power minus 2x squared minus 15x. And that is my function. Yay. Number 12, final one. So in order for an answer to be negative 2, I would have to have x plus 2. In order for an answer to be 7, I would have to have x minus 7. And in order for a 0 to be 9, it would have to be x minus 9. And then I'm just going to go through and multiply all of these. So we do our front. So x times x is x squared. Outside minus 7x. Inside plus 2x. Last minus 14. And then times x minus 9. I can combine my like terms. So negative 7x plus 2x is negative 5x. And then if I'm taking a trinomial times a binomial, so one with 3 terms times something with 2 terms, the way I like to do it is you can just, you basically have to multiply everything by everything in this term, everything in this trinomial times everything in the binomial. So you could separate it. I'm going to separate my x minus 9. I'm going to put an x here. And I'm going to take this x times everything in here. So x times x squared minus 5x minus 14. And then I'm going to put this minus 9 from the x minus 9 right here. I also need to take that times everything in the trinomial. So x squared minus 5x minus 14. And then I'm going to distribute both of them and combine my like terms. So x times x squared is x to the third. X times negative 5x is negative 5x squared. X times 14 is negative 14x. And then I'm going to distribute this negative 9. Negative 9 times x squared is negative 9x squared. Negative 9 times negative 5x is 45x. Negative 9 times negative 14. I don't know what 9 times negative 14 is. I thought I had it written on my paper and I didn't, so I'm going to use my calculator. 9 times 14 is 126. So plus 126 And then we can combine our like terms. So, and we want to put them in decreasing order of their powers. So x to the third is first. Negative 5x squared minus 9x squared is negative 14x squared.
Dustin Cooter, your ride is waiting. Dustin Cooter, your ride is waiting.
And then negative 14x plus 45. Negative 14 plus 45 is 31. I know how to do that. So plus 31x and then plus 126 will be tagged onto the end. And that's the last of it. That was a lot of steps, but it's not like super difficult and it's kind of fun. Okay, so then your assignment is on page 293. And you're gonna do numbers 7 through 12 and then 20 to 24. And then we will go over these tomorrow when I have returned from my service project, or not tomorrow, I guess Monday. And it will be dandy. Have a lovely weekend. See you on Monday.